we're going to be solving radical equations in this lesson, and also radical inequalities in this lesson. So first things first, how would you even solve a radical equation? Well, radical equations include radical expressions. In order to solve them, you have to raise the power of each side of the equation. And the way you know how to raise the power to basically is if you have a cube root, then you have to raise both sides to the power of 3, and so on and so forth. Now, because the way you're solving them, right? Because you're solving them by raising the whole equation to a higher power, what that does mathematically is introduce to the problem solutions that would normally have not been there, right? When you're squaring something. That means when you get your solutions, you may have gotten solutions that would not work. So you always have to go back and check to see if you have extraneous solutions, right? So you have to check for extraneous solutions. All right. Okay. So let's do this first one. Now, would there be a situation with extraneous solutions if, let's say, it's a cube root? Is there any? So let's say you have the cube root of x minus 1, right? Are there any values of x for which the cube root of x minus 1 is not real, or it can't be solved? If it's 1, then you have the cube root of 0, and what's the cube root of 0? 0. If it's negative 1, then you have the cube root of negative 2, and is that a problem? Not really. And what if you have like the cube root of 7? Is that a problem? Not really. What if it was a square root though? Yeah. Right? Then you have to make sure that the square root is always, that the stuff in that the radicand is always positive, right? If it's an even root. So to check for extraneous solutions, that also makes a difference, right? If it's an even or an odd root. Okay. Let's do the very first one. So basically the procedure is, as it says here, isolate the radical on one side of the equation. Raise each side to a power equal to the index. And then solve the resulting polynomial equation. Don't forget to check your results. Okay. All right, so for the first one, we want to isolate the radical here. And when we do that, we add 1 to both sides, and I get the square root of y minus 1 is equal to 6. I take a square, I square both sides. And that'll be y minus 1 is equal to 36. So y is equal to 37. So let's check. Is the square root of 36 minus 1, 37 minus 1, minus 1 equal to 5? Yes, it is. Okay, so that means that's the correct answer. All right, look at this next one. So now you have two roots. It's easiest when you have at least one root on either side of the, when you have a maximum of one root on either side of the equation. So this could also be solved if the root x was also on the left side. So we had root x plus root x minus 12. It can also be solved. It takes a much longer process though. So the easier way to do it, the quicker way to do it, is to make sure you only have one root on each side. So if they were on the same side, take one of the roots to the other side. Okay. We're going to square both sides. Square this. And here we're going to square the entire thing. So when you square the left, what do we get?
Well, you couldn't just add x.
just x minus 12, right? Equal, so we don't want to bring the square root of x to the left side and combine it with the other square root, because then it makes the process a little bit longer. Oh. I don't have my charger. Okay, so we square this one, right? I'm going to square the first one and I'm going to get a 4. Square the last one and I'm going to get an x. What do I get in the middle? Minus, not 4. Oh, 4. Plus x. Okay? Yes. We're going to isolate the radical one more time. So I'm going to subtract 4 and subtract x. Right. Luckily here the x's go away. So I have negative 16 is equal to negative 4 root x. At this point, I want to go ahead and simplify, divide everything by negative 4. So 4 is equal to the square root of x. Now I square one more time. So 16 is equal to x. So, right, so you're fast forwarding, but now let's check. So here we have the square root of 16 minus 12. And we want to know, is this the same as 2 minus the square root of 16? So look, on this side, I'm going to get a negative value, right? Well, is it ever possible that I take the square root of something and get a negative? No. So already that fails. So this is no solution. Yeah. All right, let's take a look here. Again, I'm going to isolate the power here. So I'm going to subtract 1. And I get 3n plus 2 to the power of 1/3 equals negative 1. Now, in order, if it has a fractional exponent, to get rid of it, what I want to do is I want to raise it to the power of the reciprocal. So raise it to the power of 3. Raise it to the power of 3, right? So whatever the exponent is, if the exponent is 2 over 7, you raise it to the power of 7 over 2, the reciprocal of the power, the reciprocal of the exponent. So now, 1/3 times 3 is just 1. So what I have on the left side is 3n plus 2 to the power of 1 equals what? Negative 1. So 3n equals negative 3, and n is equal to negative 1. Now, is this a square root or a cube root? It's a cube root, and what's the domain of a cube root? So the domain of a cube root function, remember, looks like this. So the domain is all real numbers. That means I'm not really restricted by the domain. So they're all going to work. All right? Okay. You can, right. All right, so let's do this one. Let's add 2 to both sides. And I have 3, 5y minus 1 to the power of 1/3 equal to 2. Now, divide by 3. And now I'm going to raise everything to the power of 3. So, this goes away. So I have 5y minus 1 is equal to 2 cubed is 8 over 27. So 5y is 8 over 27 plus 1. 5y is 35 over 27. Now, I'm going to divide by 5, which is the same as multiplying by 1 over 5. So y is 7 over 27. So much for equations. How about are radical inequalities. In this case, we have to do two things. If you have an even root when the index is even, okay, what we have to look for is the following. You have to identify the values. Why doesn't that work? All right, so we have to identify the values for which the radicand is non-negative. All right, so there are two parts to this. Then we have to solve the inequality. All right. All right, so we split this down the middle. So first I take the stuff inside the root, and I want to make sure that that's always greater than or equal to 0, non-negative. So I say 3x minus 6 is greater than or equal to 0. So 3x is greater than or equal to 6, and x is greater than or equal to 2. And I just sort of let that hang out there for a little bit. Now, I want to go back and solve the main inequality, right? To solve the main inequality, I'm going to subtract 4. So I have the square root of 3x minus 6 is less than or equal to 3, right? Square both sides. 3x minus 6 is less than or equal to 9. 3x is less than or equal to 12. X is less than or equal to 15. And 5. All right. Now what I need to do is I need to combine both of these. Right? I need to combine both of these because on the one hand, it's telling me that your values have to be greater than 2. And on the other hand, it's telling me, thank you. On the other hand, it's telling me that they have to be less than or equal to 5, right? So I need to combine them. Let's put them in a number line. So this is telling me that my values have to be greater than or equal to 2. And this is telling me that they have to be less than or equal to 5. That means where is my solution? It's in this region here. So the solution is 2 less than or equal to x less than or equal to 5. All right? So because it's a square root in the inequality, you have an upper limit and a lower limit to your inequality because you're also bound by a second condition that the stuff inside the radicand, can never be negative. All right, so let's do one more. I'm going to separate into two parts. First, do the radicand and make sure that that's always greater than or equal to 0.
Even if it was like second root of the radicand, but it would be a 4 instead of that. You have to use 2.
Yes, anytime you have an even root. Okay, so here the main equation is greater than or equal to 4. Square both sides. 2x plus 1 is greater than or equal to 16. So this is 2x is greater than or equal to 15. So x is greater than or equal to
2x plus 2 inside the square.
Oh, it's a 2. So this is a 14 and this is a 7. All right, so look at what this is telling us. On the one hand, it's saying, okay, x has to be greater than or equal to minus 1. And now this is telling me, no, it has to be greater than or equal to 7, right? You have to take the one that is least exclusive. So you have to take the one that is more precise. So you have to take the 7. Okay, not the negative one. Because even though one part is saying, okay, you can include all the numbers between -1 and 7, this one is saying, no, you can't. All the numbers that you include have to be able to satisfy both equations. Does that make sense? So for example, -2, I'm sorry, 0. 0 is 1, that satisfies this, but it doesn't work for this. So that's out. You have to pick a number that both of these people are okay with. 9. Is that okay with this? Yeah. Is that okay with this? Yeah. Okay? So you have to take one that is, yeah. I know it doesn't fit with our inclusiveness at D Toledo, but hey, it's math. Okay? So it's this one. X is greater than or equal to 7 is the only answer. Last one. So the square root of 4x minus 4 is less than 6. When I square both sides, 4x minus 4 is less than 36. So x is less than 10. Oh, and I forgot to do the first part. So 4x minus 4 has to be greater than or equal to 0, right? So even though this is less than, that has to be greater than or equal to. Because I'm okay with having a 0 in the root. Okay? So x is greater than or equal to 1, right? All right. Yes. That's fine. Yeah, that's totally fine. So greater than here, but less than here. All right, so it's like an amusement park. Anybody that is 1 up to like just under 10, like once you hit 10, you can't go, right? But as soon as you turn 1, you can go. So here we go. So 1 less than or equal to x less than 10. Will I take points off if these are off? Yes, I will. Okay? No. Yes. Okay. This homework is due tomorrow, Tuesday.